Think about the immense scale of everything we can see and touch: human bodies, planets, blazing stars, and entire clusters of massive black holes. This diagram shows the total composition of the universe, and all of that ordinary matter, everything you know, fits into a tiny sliver, making up less than 5% of it. Looking at the rest of this chart, we are left with a massive missing piece in our model of reality. Physicists categorize this remaining 95% into dark matter at 27% and dark energy, taking up 68%. These entities are completely invisible to us. They do not emit light, they do not reflect light, and they do not interact with normal matter in any way our current instruments can detect. Terms like dark matter and dark energy actually describe a profound gap in our knowledge, a signal that our current equations for how reality works are completely missing the mark. In the 1970s, astronomer Vera Rubin was tracking how galaxies rotate. Vera Rubin was an American astronomer whose measurements of galaxy rotation rates exposed major flaws in our understanding of gravity. Based on standard physics, objects further from a gravitational center orbit more slowly, just like the outer planets in our solar system. Stars at the faint outer edges of a galaxy were expected to follow that exact same rule. This graph compares those expectations against Rubin's data. Instead of the expected downward curve, the actual speeds form a flat line, showing that stars at the far edges were moving at the exact same constant speed as stars tightly packed in the center. At those extreme speeds, the outer stars should have broken free from the galaxy's gravitational pull and flown off into deep space. The only reason they stay in orbit is an invisible mass generating extra gravity. We can actually map this mass through a process called gravitational lensing. Gravitational lensing is a phenomenon where massive, unseen regions of space physically bend and distort the light traveling from distant galaxies behind them. Because of that localized gravitational pull, we know every visible star and planet only exists because it is anchored to a massive, invisible skeleton we cannot see or touch. Moving forward to the late 1990s, astronomers began measuring distant supernovae to track the expansion of the universe. Supernovae are massively exploding stars that emit so much light, scientists use them to measure vast distances across space. At the time, the baseline assumption was straightforward. The collective gravity of all the matter in the universe should be pulling things together, actively slowing cosmic expansion down. This chart demonstrates the actual rate of cosmic expansion over time. Instead of the downward taper scientists expected, the curve bends sharply upward, proving the expansion of the universe is rapidly accelerating. Physicists call this repulsive force dark energy. While dark matter pulls localized structures together, dark energy acts as a direct contrast, violently pushing the entire universe apart. Making up 68% of the entire universe, dark energy is the dominant force in reality. That means the ultimate fate of the cosmos is being dictated by something we completely fail to comprehend. For decades, physicists have dedicated immense engineering efforts to finding physical proof of dark matter, running experiments deep in underground detectors and massive particle accelerators. After decades of searching, these experiments have yielded absolutely zero direct evidence or physical fingerprints. This leaves theoretical physics facing two potential paths. Path A suggests the universe contains undiscovered particles like WIMPs or axions. WIMPs and axions are theoretical subatomic particles proposed to make up this invisible mass, potentially forming entirely hidden shadow layers of reality that bypass our physical laws. Path B is a much more radical idea. It suggests dark matter and dark energy do not exist at all, and instead, the foundational equations we use to calculate gravity are broken on a cosmic scale. If our models of dark energy are correct, it could lead to the Big Rip. The Big Rip is a theoretical apocalyptic scenario where dark energy continues accelerating until it violently tears apart galaxies, planets, and eventually individual atoms. In these scientific terms, dark signifies the limits of human knowledge, marking the boundary of what we can currently measure and explain. Every star in the night sky serves as a reminder that everything we know is a rounding error, and we are still at the very beginning of understanding what reality actually is.